So this is how we prove a universal statement with limited numbers, finite numbers. You need to check for each one of them. Now, I expect you to ask, how do I disprove a universal statement? So suppose you have the following example. Prove or disprove. The statement given to you is, for any real numbers a and b, if a squared is equal to b squared, then a is equal to b. A is equal to b. Very good. First of all, we have a universal statement. This is a universal statement. For any x in D, px, qx, rx, anything that you like. If you want to try to prove this statement, you need to use the direct definition for now. Well, I'm going to try to disprove this statement. To disprove this statement, we only need one example. If you can find that one example, which we call the counterexample, that doesn't satisfy this universal statement, then you're done. That example, that one example, is called the counterexample. Know the terminologies. Counterexample. Very good. There are a lot of examples that you can use here. -1 to the second power is the same as 1 to the second power, but -1 is different from +1. A squared is equal to b squared, but a is not equal to b. It satisfies the hypothesis, but the conclusion is not correct. So we found one example that disproves this statement. So in general, you say that this statement is not true. So let us write this down. Since we found the counter example for this universal statement, we conclude that it is false. It is a false statement. Not every statement in math is a true statement. In many scenarios, you have a false statement. In that case, you have a universal statement. You found one example that disproves this statement. So you say that, hey, I found a counterexample and I disprove this statement. This statement is not true all the time. Sometimes it is true, but it's not true all the time.